Okay, so as in the last video, we have done self-check exercise 1.2, alright, in which what we calculated, we basically calculated the mass, right, the mass of the oxygen. But initially, we know that as we are solving with the mole concept, so initially we need to find the moles, right? See, the mass of hydrogen was given, right? And we were supposed to find the mass of the oxygen, right? If mass of hydrogen was given, we need to divide that mass by the molar mass of hydrogen so that we can have the moles of that, right? When we got the moles of that, we multiplied the moles of that by the molar mass of the oxygen, and this is how simple it is. And we have calculated basically the mass of the oxygen, right? So in today's video, we're gonna solve the self-check exercise 1.3, in which they have asked us, basically there are two types, right? So in the first part, they have asked us about the moles. In the second part, they have asked us to calculate the volume of it, right? So let's read the first part first. How many moles of oxygen molecules are there in 50.0 dm cube of oxygen gas at STP? we know that STP is what? STP is nothing but it is standard temperature pressure. So let's write this here. Just very important information, right? When I was telling you guys the molar volume at STP, that was equal to 22.4 dm cube or 22.4 centimeter cube, right? Decimeter cube or liter. So standard temperature pressure, standard temperature pressure. Standard temperature we have is 7273 Kelvin, right? This is the standard temperature. However, standard pressure we have is 1 atm. 1 atm is basically used for the atmospheric pressure. Atmospheric pressure, right? Or you can say 760 torr. 760 torr or 760 mm of Hg, right? This is what we call the standard temperature pressure. At STP, the volume of any gas, the molar volume of any gas at STP condition is 22.4 decimeter cube or 22.4 liter, right? If you want to write that in the centimeter cube or in the milliliter, so you need to multiply this by the 100,000. It would be 22,400 centimeter cube or 22,400 milliliter, right? This is the molar volume of any gas at STP. Alright, now let's read the first question, what basically they have asked us about. How many moles of oxygen? Which means what they are asking for. They are asking us to calculate the number of moles of oxygen, right? If they are asking us to calculate the moles of oxygen, which means they must have provided maybe the mass or the given particle, or they must have provided us the volume, right? So that we can divide it by the molar volume, molar mass, or you can say Avogadro's number, and we can have moles of it. So they have asked us to calculate the number of moles of oxygen molecule. We need to calculate the moles of oxygen molecule which are present in the 50.0 dm cube of oxygen gas at STP. Alright, so this is the volume given. This is what? This is volume given. Now recognize, wait, let me make the data first. We're gonna solve this problem by the 5 basic steps, as I've already made you learn those. The first step is to create the data, right? Second, you need to write the required value, right? What is required? Third, you need to write the formula of it. Fourth, you need to solve it. Solution, right? Solution. Last but not the least is the result. You need to write the result of it, right? So 5 steps were there: data, required, formula, solution and result. Initially, let's make the data. What they have given us in the data, a volume given. There is given volume, right? So volume is given in the question. Given volume is what? It is 50.0 dm cube, right? And we know the molar volume of any gas at STP as well, right? Molar volume at STP of any gas is 22.4 decimeter cube, right? So this is the data we have. Now what is required in the question? What we actually need to find? We need to find the moles of oxygen, right? So let's write required is moles. We need to calculate the moles. Now we need to generate a formula. By what formula we're gonna solve it, right? There is given volume. We know the molar volume, which means now we're gonna use the third formula, which is number of mole is equal to given volume per molar volume. So we know the formula as well. Number of mole is equal to given volume per molar volume, right? Given volume per molar volume. Now in the solution you need to substitute the values of it, right? Given volume is already given in the question, that is equal to 50.0, or no need to write 0.0, right? dm cube by the molar volume of any gas at STP is 22.4 dm cube, right? So this dm cube cancel. 50 divided by 22.4, what we're gonna get is 2.23, right? 2.23 moles. So this is basically result and it is our answer, right? Let's match this answer, 2.23. So yes, the answer of the first one is 2.23, which is the right one, right? This is done. Now let's solve the second part of it. In the second part, they have asked us the volume, right? Volume. What volume does 0.80 mole of nitrogen gas occupy at STP? Which means we need to find the given volume of it, while the moles of the nitrogen is already given, right? And we know the molar volume of any gas STP as well, and that is 22.4 dm cube, right? So let's solve the second question first. We will be solving with the 5 basic steps, right? Initially we'll be making data. Secondly, we will be going with required value. What is required, right? Thirdly, we'll be going with formula. What formula we're gonna use in it. Fourthly, we're gonna solve that. So solution. Lastly, we will be going with the result of it, right? Which is also known as answer. So basically, what is the data? What they have given us in the question? They have given us the moles of nitrogen, right? Nitrogen gas. So in the data, we're gonna write mole is equal to how many moles have they given? They've given us 0.80 moles, right? And we know the molar volume as well. Molar volume of any gas at STP is what? It is 22.4 dm cube, right? So let's write that, 22.4 dm cube, right? Secondly, we need to write the required value. What is required? What they have asked us to find? What volume does? Which means they have asked us to find the given volume. Given volume, right? We need to find. Now we need to generate a formula for it. Basically, the moles are given, the given volume we need to find, and the molar volume we already know, right? So what formula we're going to apply is the third formula, in which number of mole is equal to given volume per molar volume. So number of mole is equal to given volume per molar volume, right? Molar volume. Now let's substitute the values of it. We know that number of mole they have already given us in the question, and that is 0.80 is equal to given volume we are finding. So instead of given volume, let that given volume be x, right? And molar volume of any gas at STP is 22.4 dm cube, right? This is dividing here. When it will go there, it will be multiplied. So finally the result we got is x is equal to how much, volume. It is equal to 17.93 decimeter cube, right? This is the result, or you can say this is the answer, right? Now let's match this answer. 17.93 dm cube, 17.93 dm cube means both answers are right, and we have done this by the 5 basic steps: data, required, formula, solution, result, right? When you'll be solving with these basic 5 steps, your answer would never gonna be wrong, or your solution would never gonna be wrong, right? You're gonna ace it. So in the next video we're gonna solve self check exercise 1.4. This was all for today.